Good day, Dr. Lai. My name is Un Jiazhen, and today I will be presenting an ECG signal amplifier using MOSFET in biomedical electronics. These presentations will explain how MOSFET are used in ECG circuit to amplify weak electrical signal from human heart. I will also discuss the importance, working principle, applications, advantages, and limitations of this biomedical electronic system. First, let us understand what is ECG. ECG stands for electrocardiogram. It is a biomedical device to use to measure an electrical activity generated by the heart. During an ECG measurement, electrodes are attached to the patient's skin to detect electrical impulses produced during the heartbeat. This signal will display as waveform to help doctor analyze heart conditions and diagnose abnormalities such as arrhythmia and heart disease. ECG systems are widely used in hospitals, emergencies unit, clinics, ambulances, and even wearable health monitoring devices. One major challenge in ECG system is that the electrical signal produced by the heart are extremely weak. Typically, an ECG signal ranges from only about 0.5 millivolts to 5 millivolts. Because of the signal are very small, they can easily be affected by external noise such as power line interference, body movements, muscle activities, and surrounding electronic devices. Hence, the ECG signal cannot be directly processed or displayed accurately. To solve these problems, an amplifier circuit is needed to strengthen the signal before further processing. And now, let us look at the MOSFET. MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. It is an electronic device commonly used for amplification and switching in electronic circuits. Unlike BJT, MOSFET is voltage control, meaning that a small voltage applied is gate terminal and can control a large current flow between the drains and source terminals. MOSFET is widely used in biomedical electronics because it provides high input impedance, low noise, and low power consumption, which are very important for handling weak biological signals such as ECG signals. There are several reasons why MOSFET is suitable from ECG amplifier circuits. First, MOSFET has very high input impedance. This prevents loading effects and helps preserve the original ECG signals. Second, MOSFET produces low electrical noise, resulting in cleaner and more accurate ECG waveform. Third, MOSFET consumes very low power, making it ideal for portables and wearable medical devices. And finally, MOSFET is highly sensitive and capable of detecting extremely small biological signal from the human body. And this slide shows the basic ECG signal flow. First, electrode attached to patient detect electrical activity from the heart. The weak ECG signal is then sent into the MOSFET amplifier stage. At this stage, the MOSFET amplifies the signal so it becomes stronger and easier to process. After amplifications, the signal passes through filter to remove unwanted noise and interference. Finally, the processed ECG waveform is displayed on the monitor or recording system for the medical analysis. Next, I will explain on how MOSFET amplifies ECG signals. The weak ECG signals enter the gate terminals of the MOSFET. Small voltage changes at the gate control, a larger drains currents flowing through the devices. As a result, the signal amplitude increases, producing an amplified output signal. One common amplifier configuration used in the common source amplifier, which provides voltage gain from signal amplifications. This amplified signal can then be processed more accurately by biomedical monitoring system. MOSFET-based ECG amplifier circuits are widely used in many biomedical applications. First, in hospitals and intensive care units, ECG monitoring system continuously observes patient heart activities. Then, the portable ECG devices also allow the patient to monitor their heart conditions at home. Last but not least, the wearable device such as smartwatches also use ECG sensing technology for real-time heart monitoring. This application demonstrates how MOSFET's technology support modern healthcare systems and improve patient monitoring. And now, let us discuss the advantages and the limitations of MOSFETs in ECG system. Some advantages include accurate signal amplifications, low power consumption, compact circuit size, and suitability for portable medical devices. However, there are also some limitations. MOSFET device can be sensitive to static electricity and require proper biasing to operate correctly. In addition, complex filtering circuits may still be necessary to remove environmental noise from ECG signal. In conclusion, ECG signals require amplification because the electrical signal from the heart are extremely weak. MOSFETs play an important role in ECG amplifier circuit due to its high input impedance, low noise characteristics, high sensitivities, and low power consumptions. These features help improve signal qualities and measurement accuracy in biomedical monitoring system. Therefore, MOSFET's technology is widely used in modern ECG devices and contributes significantly to the healthcare and patient monitoring. These are the references used in preparing these presentations. Thank you for listening to my presentation.